In one of the lower rungs of the Liebreich ladder is the fuel cell car, the hydrogen-driven fuel cell car, the best exemplified by the Toyota Mirai 2. When compared to the Tesla Model 3 long-range all-wheel drive, which is a battery electric vehicle, the price, curb weight, range in miles, and the number of seats are all pretty much the same. But when you look at the luggage or cargo space and the acceleration, they're very different. When you consider the mass of the fuel consumed, you have to add the weight of the tank. And in the case of hydrogen, it has to be a strong, heavy tank to contain 700 atmospheres of pressure, which is what the hydrogen is stored at. A lot of the mechanical energy that goes into storing hydrogen in a tank is all lost when you use it to refuel an automobile. That energy is equivalent to the potential energy of a car dropped from 5,000 feet in the air. But the engineers at Toyota came up with an aluminum tank and wrapped it in carbon fiber, which has a very high tensile strength, and so it won't expand for the pressure inside. So they save some weight. Hydrogen has what is called the negative Joule-Thomson coefficient. Different from many gases in that when it expands, coming out of the tank, it heats up, it doesn't cool down. Which means that you have to cool it down as it's coming through the hose into the Mirai's tanks, because otherwise the Mirai's tanks will overheat when you fill them. There was a Baja Fuji 24-hour race that Toyota entered the Mirai in. It took 4 tractor trailers to fuel it. It was not a fuel cell, but internal combustion engine model. So it was combusting the hydrogen, not running it through a fuel cell. 2 of the tractor trailers were required to bring the hydrogen in tanks. 1 tractor trailer carried the compression and cooling equipment. And the 4th brought the generators and fossil fuel needed to run everything. 4 of the 24 hours of the race were used for refueling the car.